But good morning, good afternoon, or good evening to wherever you are in the world or in Canada. Welcome to today's Climate Connection series, which is focused on water. With gratitude and respect, we acknowledge that we're joining from the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples, and are now home to many diverse First Nations, Inuit, and Métis peoples. I acknowledge that the lands that I live and work on in Ottawa is the traditional and unceded territory of the Algonquin Anishinaabe people and respect their traditional knowledge and healing developed over generations. I invite you to take some time to think about and acknowledge from whose territory you're joining today. So, the climate imperative presents enormous challenges for industries that must now align their strategy and operations with the goal of a low carbon economy. And as industry steps up to meet these pressing new climate challenges, there are exciting new opportunities for the translation of research into impact. Enter Climate Connections, our problem-driven event that connects solution seekers from the industry with researchers and innovators from academia and fosters cross-sector connections to address the climate challenge. This series brings together industry experts who present short reverse pitches on the challenges that they see. I want to give a shout out to our academic partners of Climate Connections. Thank you to Entrepreneurship at UBC, Simon Fraser University, McMaster University, and the Impact Investing Hub at the University of Victoria. We're quite proud of these academic partnerships that we have in this event, and we have many more collaborations in promoting these events in the near future. So just a quick rundown of how our event is going to go. We'll kick it off with a bit of an intro and welcome our wonderful industry expert panel. I'll pass it over to them to each go through a short presentation to give an overview of their real world problem. Then we'll head into a moderator. Feel free to put questions in the chat during the presentations. For those of you who are less familiar with Foresight, Foresight is Canada's clean tech accelerator. Our big, hairy, audacious goal is that we see Canada become the first G7 country to achieve net zero. To do this, we're bringing partners together to identify, commercialize, and adopt the clean technologies needed to address today's most urgent climate challenges. Using our Helix 5 model, we bring together industry, government, academia, investors, and innovators to address today's most urgent climate issues and support a global transition to a green economy. And there are many folks from the Helix 5 model that are represented in this event today through panelists and audience members. So thanks for being here with us. We work across 5 main areas, which is our accelerator programs, our innovation challenges, our capital attraction opportunities, as well as export development and ecosystem building. We support our companies through all of these various aspects. Over to our wonderful panelists, introducing Chris Godwold, who's the CASIA Water Director. Chris works with CASIA member water experts, aligning their research and technology development efforts. Chris has lived and worked around the globe in technical, marketing, and managerial capacities on projects ranging from individual consulting contracts through to multi-billion-dollar regional projects, and has been a part of several technology startups. Chamarai Nyabeze holds a bachelor's degree in mining engineering and an MBA, and as the VP of Business Development for the Center for Excellence in Mining Innovation and the Network Director for the Mining Innovation Commercialization Accelerator Network, he focuses on creating long-term value for organizations and clients. Chamarai identifies business development opportunities in both the public and private sectors and aims to generate revenue with leverage funds, foster collaboration, and expand networks. I will hand it over to our WaterNext strategic advisor, Evan Pilkington, to kick off the moderation of the session. Evan, over to you.
Super. And thank you again, everyone who's joined us today, and certainly to our panelists. We really appreciate it. At this time, again, as Benita has mentioned, please feel free to put questions as we go through these presentations and introductory discussions. And I will then read through these questions for you, and whatever we address during this panel discussion will be brought up. But then, of course, we'll have the chance to share these questions with our panelists who may be able to answer them offline or follow up with you afterwards. So please feel free to add them as we go. And first, we'll start with Chris. If we could pull Chris's slides up, then he can carry on. And immediately after, Chami, if you could join right after Chris, and then we'll open it up to some discussion. So thank you very much.
Here we go. Okay, well, good morning. My name is Chris Godwold. I'm the Director of Water at COSIA, which is a division of Pathways Alliance. COSIA is made up of oil sands producers, including Cenovus, Suncor, ConocoPhillips, Syncrude, and Imperial. So and they are accounting for about 90% of oil sands production. Like anything else, when you're talking about technology, you need to provide some context. So I'm going to provide a bit of context, and then I'm going to dive into what the innovation we're searching for is. So, all right, just a little bit about COSIA and Pathways. I'll leave that up there for you to read and see afterwards. $1.8 billion in technology developed, 531 active projects ongoing right now. So we've got a significant amount of work, and I deal with 13 different technical working groups at this point on a significant number of projects. We're going to talk principally about in situ today. So of the oil sands resources, 80% are too deep, and so these are extracted using putting steam into the ground, which is then recovered. And we're actually going to talk about produced water coolers, which are on the surface. But wanted to provide you that context. So steam is generated, goes underground, and comes back up. If we take a look at the facility we're going to be talking about, we start by injecting steam into the ground. It comes in. We then remove the oil. We then remove and clean up the water itself before steam is created, and it's put back down underground again. In the red box are the produced water coolers, and that's what we're going to talk about today. Just some background information. This is one of a number of areas that we work in. This is within the inlet separation and de-oiling area of a water plant, but we have challenges in the areas of water, steam, process monitoring, which are analyzers, process control automation, asset integrity, how we keep our assets operating, and how we take them down, repair them, and put them back up again. So those are all available. Additional information. So part of deploying anything is where can you test it? And because our facilities only get shut off every several years, we need infrastructure that allows us to test them. We need infrastructure that we start at the lab scale in beakers, we then move, we'll call sort of bench scale things, or things sitting in warehouses, for instance, the high temperature membrane test facility, where we can test it by trucking water to a facility. We then need to move on to actually on-site facilities. So this is the Water Technology Development Center, $143 million facility live coupled to Suncor's Firebag. So you can take live hot coupled waters and eventually test it, making it simpler to take things to field deployment done. So again, research priorities, I'm going to leave that there for you. Again, more research priorities. So just information for you in the background. What I'm going to talk today about, what the area we're talking about today is improving the performance of in situ oil sands produced water heat exchangers. So the water is coming out of the ground at hundreds of degrees Celsius. We actually end up cooling it down to ambient in a number of different steps, which changes the chemistry of the water. But we do that using heat exchangers or produced water heat exchangers, and principally shell and tube. So essentially the processed water is passing through the tube with the heat exchange fluid passing around the outside of the tube. And these foul. The insides of those tubes, as we drop the temperature of that water, we end up with all kinds of fouling, both organic and inorganic fouling occurring on those tubes. That's what we're looking for some help with. So we're looking for ways to improve the performance of these heat exchangers by reducing that fouling and that scaling formation. And we end up having to take these offline. So the longer we can run them, the better off we are. The longer we can keep it in an operation, the less of these we need. So the less capital resources we need, the less environmental goods which are used to produce those, and the less chemistry as well. So when we take a look at the background here, like I said, we've got shell and tube or spiral, typically spiral, and the ones I'm going to focus are really the water cooled. And they're typically used in facilities that produce about 15 to 30,000 cubic meters per day. And we put multiple of these in service. So there are literally hundreds of these in service at this point. So the market for a solution is significant. Again, fouling is building up on those. The fouling creates resistance and reduces heat transfer. which results in wasted energy, which we then have to burn more fuel to make up for. Again, natural gas is used to heat this water up, and the less heat transfer loss we have, the less natural gas we burn and the less greenhouse gases that are emitted. And at this case, you've probably heard in the news, the oil sands producers are committed to capturing a good portion of the greenhouse gases that are produced. So producing less greenhouse gases, combusting less fuel, and to do that, it means that less will have to be captured in the end. And so fouling, we're looking to reduce the fouling through the use of anti-foulants during operations, right? Or to reduce the amount of time between the cleaning of those. So what are some of the key requirements we're looking for? So first of all, whatever we're doing has to be compatible with produced water characteristics, which I'll have a little bit later. They have to be applicable to a wide range of sizes and configurations. They have to extend the time between cleanings, and they need a lower life cycle overall operating cost than our incumbent technology. So we'd also like to see that the thermal conductivity is higher, meaning better. So there's more heat conducted from the process fluid to the heat transfer fluid, and we need them to function at up to 135 Celsius, preferably even as high as 165 degrees Celsius. Be that either a product, a chemical, or an invention or an idea. What is nice to have across a wide range of foulants and scale forming compounds, that it would last multi-years. If it's a piece of hardware, they can be mechanically or chemically cleaned, preferably mechanically. So if we're talking about putting something inside it, on it, perhaps a coating, we have to look at the ability for that to be cleaned, because we expect that fouling will continue to happen. Because we have so many of these installed, we would prefer solutions that can be applied to existing facilities, but we're open to solutions which could be applied to the bundles themselves. So in many cases, after a certain number of years, the bundles are removed and have to be replaced. So either that, so a replacement bundle, or as we put new facilities in. So we could take those out to change them out, or in new. We do see thermal cycling. So between 80 and 135 C normally, again, with excursions up to 160, or even as high as 180. What we don't want is it to be rougher than the carbon steel that's there today. So if we can make it smoother, that's even more preferable. What are some of the things that we're interested in? Chemical additives, that's a lot of what we do today. Coatings, can we put a coating onto the tubes that will make it last? Physical enhancements, something that would put spin on the water, something perhaps that would move throughout the flow, a product that we could take and insert into it. Other innovative ways of cleaning things. We have to clean them offline today. Can we somehow do this without stopping the process or without taking things apart, so that we can get longer runs? Finally, a little bit more information on the exchangers themselves. So again, shell and tube, so tubes running through the middle versus spiral. We do have some air-cooled designs. I'm not going to focus on those. It's really water-cooled. These tubes, to be really specific, we're looking at 3/4 of an inch to 1 inch with a tube wall thickness of about millimeters, mixing inches and millimeters there. But the tubes are typically about 20 feet straight. So whatever you're doing, you need to be able to run up to 20 feet into it. Some have used, but very, very uncommon. The material of construction is almost exclusively carbon steel. And the flow through those up to 1 inch tubes is about 15 to 30,000 cubic meters a day. So significant flow volume coming from them. And the scale itself is typically soluble organics or insoluble organics, and then inorganic, so just elemental fouling, like you would see in your taps. Those are the kind of things you will more likely see at home versus the organics of the things you hopefully don't see at home in your kettle. And again, process information. So this is the environment you're going to operate in. Operating temperatures over 135. pH is fairly neutral. Alkalinity, that information is there, and I'm just going to let you look at that. And that's the kind of thing we probably can't digest during the presentation, but it would be available for you afterwards. That was it for that. I'm going to make you aware of an area. Analyzer is an area that we are typically looking for solutions in, but I'll just leave that be. And if you want more information. And with that, Evan, I'm done.
Geez, Chris, I really appreciate that. As somebody who works in, focused on the adoption of innovative new technologies and helping to promote those types of activities, this was a really great, very rapid run through on something that I think is it's a very complex challenge. And I've got a group of questions for you about this, and I'm looking forward to digging into it afterwards, primarily so that you get thinking about it in advance. I have a lot of questions for you about the process for how you're speaking on behalf of, and so will Chami be speaking on behalf of a collective membership, right? A group of industrial partners. And I'm very interested in how you are triaging and then prioritizing the types of challenges you're facing. Additionally, how these problems come to light, knowing that you are part of an organization, you must be met with a variety of issues, specific to meetings, but then also brought to you anecdotally. And I wonder how you bring these to light. So I'll be looking forward to digging into that. And I'm sure our audience will be interested in hearing about that as well. But for the time being, I'll give you that as some food for thought, but I'll look forward to, if we could, switch control of slides over to Chami, and we can hear about his work in a very parallel and interesting industry as well.
Awesome. Thank you. All right, everyone. I'm just going to share my slides. Evan, maybe just give me 2 thumbs up if you see my slides.
Perfect.
Awesome.
Thank you.
Love it. Thank you. All right, everyone. I'm going to be speaking to you today about addressing water challenges in mineral mining and processing. And I'm going to give you a bit of a big picture view so you can see where all the opportunities are to help us to make the mining industry better than what it is today. Again, my name is Chami Charles Nyabeze, and I'm the VP Business Dev for the Center for Excellence in Mining Innovation. And I'm also the Network Director for an amazing network that we call MICA, M-I-C-A, which stands for Mining Innovation Commercialization Accelerator. So over the next 14 minutes or so, I'm going to walk you through a lot of information, and hopefully it will spur some thinking in your mind and some questions, and hopefully some interest to help us make our industry better than what it is today. So just to get going, I want to start off by letting you know that I work for an organization that is 15 years old now, SEMI. It's the vision for SEMI is to solve the challenges of the mining industry as soon as possible. And our mission is to advance innovation. And one of the techniques that we use to advance innovation is our network. So we have this network that is specifically designed to help move innovations into the mining industry in as fast a way as possible. And a little bit about that network. So MICA is a national network, and it's built to commercialize innovations into the mining industry, and in particular, harnessing the power of the SME-based innovations to create what we're calling a national mining technology ecosystem. So we work with many different partners in the industry, and we work with many organizations that are moving in the same direction to help the industry become better. Our network, the MICA network, has 6 main partners across the country. So we've got a footprint in British Columbia through BRIM, which is the Bradshaw Research Initiative for Minerals and Mining, Innotech Alberta, which is a subsidiary of Alberta Innovates in Alberta, of course, Saskatchewan Polytechnic in Saskatchewan, and move over to Ontario. We've got Mars Innovation, which is part of our main partner network, and MISA in Quebec, and on the East Coast with the College of North Atlantic. The reason I want to mention these organizations to you is to give you the idea that we are actually interested in tapping into the assets across the country that are producing innovation. And at the same time, we want to connect to these other regions so that we've got this connected ecosystem. Else we end up with a lot of different silos, and we end up with a lot of reinvention of the wheel, which we don't want to do in this time where mining is so critical to the future of the world. The MICA network has 4 technical focus areas, and these also relate to the water piece, and you'll see how they relate in a moment. But productivity, energy, smart, and environment are the areas where we're focusing in making the mining industry better. And we do touch on water on all these different components. So just to set the context for the conversation, Recently, it's actually yesterday, there was an article that came out that quoted the Fraser report. And this article said that the world needs 388 new mines by 2030 to supply the metals crucial to manufacturing EVs and other batteries. So that's 388 new mines. And I'm not even talking about the mines that we need to produce the infrastructure that we need, the homes that we need to build, the roads that we need to construct, and all these other things that we need. But 388 new mines by 2030 is a lot. To date, there's about 340 or so mines operating, metal mines in Canada and the US today. So 388 is our target for 2030. Today is 340. And so these 388 future mines that we're envisioning to have, you can see here, we want to have 50 additional lithium mines, 60 nickel, 17 cobalt, 50 that produce cathode material, 40 anode materials, 90 the cell structures, and 81 to produce the actual vehicles, the frames of the vehicles, and everything else. So 388 mines is what we need to do. But here's what the issue is, though. If we want to have all these new mines, it means all these new mines are going to demand more water, a lot more water than what we have right now. When I was putting together this presentation, I was thinking, oh, maybe I should have, how many liters, how many gallons, etc. But I said, you know what? That's for another day. So take my word for it. We're going to need a whole lot more water. So here is the issues in mining. And here is where we want to see technology pop up to help us out. Mining today has been responsible for polluting local river systems, impacting groundwater, reducing levels of groundwater, contaminating groundwater. Mining has been responsible for depleting surface water, also creating a scarcity for fresh water. Acid mine drainage is a big one. That's why I highlighted it. It's a big deal. Failing tailing dams, impact on agriculture, human health, impact on flora and fauna, and legacy and contamination. And this is not even to mention the operational challenges associated with water in mining. But 388 new mines is what we want to see open in the next little while. Communities will not allow new mines to open if these challenges are not addressed. So if mining doesn't address the water challenges, we are not going to get new mines. And if we don't get new mines, we're not going to be able to have the green transition in the way that we're all envisioning it to happen in the future. So now when I look at some of the new technologies that we are looking for in the mining sector, some of the technologies, what we are desperately needing for them to become better is seawater desalination technologies. We have some, but we want to get better at the technologies. Water transportation infrastructure is required, high-grade mining. This means that we want mining methods that are going to allow us to actually demand less water. We want to employ technologies like ore sorting technologies, things that allow us to do coarse particle filtration, which prevent downstream problems, dry disposal of mine tailings so that they're not all full of water. We need decision support systems. We need real-time monitoring. We need like right now monitoring when it comes to water. We need wireless sensor networks. We need emergency response systems when water storage facilities fail or become problematic. Water management is a big issue. We need technologies around this area. We need water treatment technologies, and we need technologies that can help us to monitor things like water outflows. So what's the impact? Because mining is a business, right? Mining is a business. And because it's a business, it has to be obviously financially responsible. So mining wants to save water, save utilization of water, which will result in reducing costs, energy efficiency. We want to reduce our energy consumption. We want to have more conservation of water, more stewardship of it, reduce usage of water, reduce contaminants that are found in water. And some of those impacts include reducing reagents that we need to use in our systems. This results in increasing productivity, improve water quality, and also that whole usage optimization piece is important. So where do we get our water from? Lakes, streams, rivers, groundwater, commercial water service supplies, desalination plants, rainwater, recycled processed water. And I actually wanted to touch on that recycled processed water as an area where we could actually have more conservation. So technologies that allow us to make that water that we currently have within the process, recycle it, is important. So there are competing uses of these water sources that require mining to minimize impact. So I thought I'll bring that as a very important component for the mining sector. So you may ask the question, where is water used in the mining? And I'm going to get a little more granular on this. But if you look at the mining value chain, and again, I'm talking about all mining here, all mining, you name it, whatever your favorite mining is, I'm talking about all mining. So all mining starts with prospecting, there's exploration. Exploration, we drill into the ground, we use water to power drills. So there is already a water impact at the exploration level. There's impact of water on the construction of new mines. Then where most people think the biggest impacts are is on the whole production mineral processing piece, where we're touching water in various areas, and we'll expand on some of these areas in a moment so you can see where those opportunities are. So if you have an idea, you can plug your idea into one of the areas. Tailings and waste storage is a big area, remediation and mine closure, and then the post-closure management, just monitoring to make sure that the water that is going to the communities is not being impacted by mining. So you can see from here that these are the areas where in the mining value chain where we want to see mining reduce impact on water. But more specifically, water and mining is in the area of transportation of things like the ore, the waste in slurries and suspension of those slurries in water, separation of minerals through chemical processes, physical separation of materials such as things like centrifugal separation, cooling systems, dust. Dust is a huge consumer of water, and that we need to mitigate and reduce the dust. We reduce dust in mineral processing, transportation, washing, roads. And again, remember, this is all competing with utilization of water in other areas, in particular near communities. Dewatering of mines is another area where we touch water a lot. Drilling, as I mentioned earlier on, and then another big example is the tailing storage. And I want to just touch on that tailing storage to show you a huge utilization of water on tailing storage. There's something that's called subaqueous deposition, okay? And it's just a process of depositing materials and substances underwater to prevent oxidation. You just hide them from the oxygen so that they don't end up oxidizing and producing this acid mine drainage. So this is a huge utilization of water. If you can imagine acres of tailings that have water to cover them, that's another way that we need to make sure that mine doesn't end up doing a lot of that. So now I'm going to jump into some examples, and I'm going to kind of fire hose you with a bunch of examples, just so you can see where mining is working with water. And I think we'll give you a good kind of overview of where we are looking at helping the mining industry with real examples. So I'm going to fire through them. ABC Dust, the dust part of it is really what they do. They reduce that dust. They use water, of course, with other chemicals to reduce the dust that is flying all over the place. And they use a little bit of AI as well to stabilize the soil. So a big utilization of water across the world is dust mitigation. Another area is just treatment of water through using things like sunlight. But again, water is really the fundamental component that is used in this technology for water treatment and water management. Another company, WaterStrider, is using a technology to remove dissolved metals from mine water. Again, mine water has got elements in it, and there'll be a few examples that will talk about how we are looking at extracting value from that mine water. Another example is Copperstone Technologies. This technology uses a robot that goes on tailings that are really muddy, full of water in them. And again, we need to be able to make sure these tailings are behaving as they should. So this technology allows us to actually measure what's happening on those tailings. And this technology has applications even in the oil sands industry. N-Twist is another company that's looking at smart comminution. Comminution just means breaking down the rock. If you can be smarter about how you break down rock, you're going to use a whole lot less water, because mineral processing technologies use a lot of water. So there's another technology where we're using AI predictive analysis to mitigate that comminution and optimize it. Environmental is a gold recovery technology, which is using less water, but more importantly, using less reagents. Actually, no reagents. They're not using cyanide and mercury that's normally utilized in gold extraction. But the technology is going to reduce the amount of water that's used in gold recovery. Another technology is Novamera. I think you remember earlier on I mentioned about how we should build the mines and how we're extracting the grade of the ore itself. This technology allows us to do what's called surgical mining. Surgical mining allows us to just go and extract what we need and not extract a lot of waste. Again, reduces the amount of water used in the water mineral processing processes. Tibet Technology is out of Newfoundland, and they have a technology to extract decontaminate toxic waste from abandoned asbestos tailings. And again, because of the technology, the amount of water utilized in the processes actually gets reduced. Rock-Best Technologies is using a technology that reduces the energy used to break down the rock. Again, if we can break down the rock easier, if it's a little bit less less hard, reducing the bond work index, we're able to actually optimize mineral processing and reduce water utilization. Telescope technologies, another one, it's using a carbon negative production of lithium carbonate. And I think you all know the brines, the whole story of the brines, right? We want to make sure that we don't end up consuming too much water or locking too much water into process. So this technology does that. Another technology in that same sort of area is a direct lithium extraction technology that uses nanotechnology to do selective processing. And again, another mechanism where we can do selective processing, reduce the amount of water that we're utilizing, because mining uses a lot of water, right? Now, technologies from DMT Technologies, this is more so on observing the tailing sites that hold a lot of water-bearing tailings and being able to monitor them to make sure that they don't end up misbehaving and breaking and causing a bunch of environmental problems. Where mining gets a lot of its reputation is tailings issues. Another company is Miracle, bioleaching technology using microbes, another mechanism to extract value out of minerals. So you can see here that with mining, we can actually use water-bearing rocks by using this biotechnology to extract value from them. So again, this is another technology where at the end of the day, we end up with a separation of water and actual mineral value. Destiny Copper has a technology that is using waste to extract copper out of solution. And again, if you look at their process, at the end of the day, you end up with a blue liquid solution where we use things like different electrical applications to actually separate the copper out of a solution that has water in it. And then that water that we separate, it still has some reagents in it that we need to be removed. So there's another requirement to make sure that we're cleaning out the water that's coming out of the processes. And as I said, I was going to fire hose through these examples, and I'm done. Thank you very much. I'm going to hand it back over to Evan. Thank you.
This is fantastic. Thank you so much. I really enjoyed that. I'm going to open up the chat while we're here, so feel free to add questions as we go. But something that I noticed in our conversation and in your presentations that you both have in common, obviously, is that the two of you are representing large industrial groups, right? I mean, the membership of your organizations represent incredible industries in Canada, major economic drivers for this country. The other thing you have in common was a massive list, huge bullet points that I'm going to have to go through after this, related to your range of issues that you as an industry partner needs to wade through to find solutions for. How on earth do you prioritize? Is it set by your membership? Is it done internally? Do you post challenges in hopes of response? Do you try to tackle all of these things? Chami, if you're willing, could you give us some insight into how these are prioritized? Because I'm sure the researchers and companies in our audience would be very interested in knowing where and when to insert themselves.
Thank you for that. You know what? I'll answer the question in a bit of a roundabout way, because there's not a one sort of door. There's not a one door, where you can sort of say, here's where I find all the challenges, right? Certainly, the MICA network is looking to become a door where all those challenges can be highlighted for the purpose of the National Innovation Network to see what the issues are. But we get innovators and entrepreneurs knocking on the door saying, I've got a solution that is in this specific area. Can you help me moving forward? So we do get that incoming from that way. But because we've got the 6 main partners, right, we've now created these individual regional doorways for technologies to come to surface. And, with technologies coming to surface, where we want to play a role as the MICA network is on late stage developed projects. So there is gateways for fundamental research in water technologies, right? And then there's also, the startup community where the startups are being assisted. And then if you kind of go up the chain, you go to where there's maybe a need for follow-on funding that addresses. So there's various organizations that Canada has. Foresight is one of them. Organizations like CDL, Plug and Play, Mars. All these organizations are trying to work to move these technologies up the level. But where we play a role is that we want to be able to bring visibility to the mining companies on what exactly the opportunities are for them to be able to find solutions. So we want to be able to curate these emerging solutions and then be able to present them before mine operators. I think when you get organizations like COSIA and Crane, they already have a bit of a membership around who they can present solutions to. We're trying to create that for the broader mining ecosystem, to create this place where technologies that are incoming can become visible. Now, the operators themselves have challenges, and they communicate the challenges down to us, and then we share the challenges with the broader ecosystem to flush out where the solutions are, so we can encourage more made in Canada solutions to be commercialized.
Amazing. That's very helpful. I'll be interested after to find out how receptive and interested your membership is in learning about these and how that happens. But Chris, do you find as well that this is, that these priorities are driven by your interest in discovering a range of possible solutions and seeking prospective adopters? How is this driven?
In our case, we sit down with the technical experts from the companies. And so I engage, and if you looked at that list, perhaps inlet separation and deoiling. So on that part of the process alone, I have a conversation, and I have all of the operators, research folks, and then I have the operations folks that sit there, are part of it. So that one area of the process, we meet monthly to talk about their challenges and to talk about places. So literally, we are dealing with the problems that matter to them today. And we're dealing with sort of answering fundamental questions to allow them to produce step changes in performance. So in each of those areas, we've actually broken it down into really, really detailed areas. So produced water coolers sit within inlet separation and deoiling. It's one of a number of challenges that we have, and it's one that they've specifically said, let's reach out a little bit further on. So that's how we categorize, and that's how we prioritize those, by dealing with the people that have the problem. They are cleaning those coolers, they see the pain, they are looking for it improved. So you really, we're pretty close to the end user. The end user is like one step away. And my role as technologies come in is to make whoever's submitting it as successful as possible, help them to understand our business. The single largest barrier is to understanding the business. And the one other group that prioritizes challenges are the vendors. Everything we buy from people that know our businesses really, really, really well. And so not only talking to us, but talking to vendors that are currently selling solutions into our business, because they know us, they're continually working to improve. So they're sorting and they're prioritizing. They know our business. And for instance, if you talk to somebody that's selling a produced water cooler, they would love their product to last longer. So talk to the vendors, because they are continually innovating.
It's amazing. And what you're both speaking to, certainly in Chami's comment also about working with mature companies who have commercialized products and proof of concept. From a slightly earlier stage, what is your relationship with primary research? Do your organizations and do the members find motivation in supporting research in that early, perhaps even academic realm, to sort of potentially develop IP that could be commercialized ultimately? How supportive are your members of these types of activities? Chami, feel free, please.
Oh, thank you, Chris. Yeah. I'll quickly say, first of all, the source of the innovations that we are now looking to commercialize have come out of the Canadian ecosystem, which includes research, right? So some of them have actually matured out of primary research, and we know technology that have emerged out of Laurentian University, out of primary research that happened many years ago, and now it's matured enough to get to where it is. But I want to add that there's still a role to be played by early stage research in customization of technologies. So there is a relationship that we have with research, which is looking at that end of the spectrum, right? Where we're saying, here's a technology that is somewhat developed, it needs some customization to move forward. But when we do observe challenges that have no solution to date, we do inform primary research on it as well. We have universities as part of the MICA network. We have also colleges that are part of the MICA network. So we do have that kind of connection to fundamental research. The one area that we're not actively involved in is in directly supporting primary sort of idea-based research at the very early stage. We just know that if we're going to make an impact on the existing operations today quickly, because again, there's this urgency, right, to get the mining industry to get to the next level, we want to be able to feed the mining industry with things that they can use now.
Does that match your sentiment as well, Chris? Are we really looking at, and I would take this as correct, that there is a certain level of urgency that is reflected in the types of partners you engage? Is that mostly the interest of your industrial partners as well?
Certainly, we pull together those users, so the people that are operating those facilities and care about a solution tomorrow. But in our business, it's amazing how much of what we do is just based on experience instead of fundamentals. And so I'm in the process of renewing 7 research chairs right now. And we're starting a research chair on produced water coolers. We actually don't understand the science. Through experience and trial and error, we know what chemistry works, we know what things worth, but we've said to make a step change in performance, our water is complex. We actually need to understand the fundamentals. And so, yeah, we do a massive amount of fundamental research in areas where we say we don't understand the fundamental science. In that area of produced water coolers, the water is complex, the interaction with the chemistry is complex. In the area of our once-through steam generators, inside we've got water and we've got massive amount of heat being applied to it. The science is we're pushing the boundaries of science. And so, yes, we absolutely do both. We want practical solutions used tomorrow, but we believe that step changes evolve from primary research. And as a result, the members' primary research is tougher to justify on your own. But when you can get the entire industry together and you can say, yes, we all agree, all of our produced water coolers are causing a problem. So we've gone out and we're launching challenges on better coatings, better all kinds of other things. Let's get a professor to take a look at the fundamental science. We'll then put that into the public domain so that all of those vendors and solution providers can build on the fundamental science, because that's how we're going to get step change.
That's really interesting. And I guess to echo a recent question from the chat box, I think a natural next question would be that applying to your organization or bringing your technology forward to the attention of your membership is of interest to many people in the audience, of course. Do you find that to get to a point where a technology has been vetted or ready to be put forward, that there is a need for testing and validation first? Is it a matter of applying at certain critical times? Is it participating in, Chris, you had a slide related to your validation and testing facilities for performance vetting. What is the process for getting, what could be perceived as an ideal solution in front of your audience? Chris, I mean, knowing that you had this slide about owned facilities for testing of such, I wondered, could you share some, or maybe there are gatekeepers, maybe it's speaking to the engineering firms that are perhaps frontline testing and recommendation vehicles for these major industrial partners? I don't know, Chris, and then Chami, if we could talk a bit about that, I think this audience would be very interested.
Yeah, and the first step is always know your business and always be humble. Always, it's that investing and understanding and just that curiosity. So through COSIA, we have the Environmental Technology Assessment Portal. So we bring people in, and they would, if you tag water, it comes to me. And really my role is to look at people and say, how can I work with you to help you understand our business so that your pitch is as successful as possible? I find the largest reason that people don't succeed is they simply don't understand the business. And I've seen Fortune 50 companies coming in saying, I've got an amazing technology to separate oil and water. Well, we actually do that pretty well. So it's knowing the business and knowing the challenges more than anything else. But I do fit, we're in a unique position in that everything that comes in gets looked at. I work with those folks, and then it goes in front of the actual people that need the solutions themselves. But literally my role is to help them make them as successful as possible, or to very quickly say, amazing technology. I can see how it can be sold into many other businesses, but it's not part of our business. And so I guess there's two things: understand the business well, but also understand that a lot of stuff we see, because it is specific, won't fit this business, but I can see it being sold into lots of other lines, having worked in water around the world.
And I think that's fairly unique and maybe encouraging for the audience, that it sounds as if, inquiries and the opportunity to engage with you about their technology is fairly direct. I think that sounds very encouraging. I know, of course, there's a digital pathway at play and some timing, but I mean, the opportunity to discuss relative solution power and the opportunity to get in front of your audience directly with you would be very encouraging, I'm sure.
It will go in front of one of those specific technical user groups. I mean, success rates still to get to, you know, to get engagement is probably about 1 in 10. But if you look at a VC firm, the success rate is an order of magnitude lower. So
Yeah.
to actually get their time, and what you want to do is just make folks curious. Really, we're dealing with the scientists and the folks that want solution. Make them curious. Don't come in saying, I've got your solution. It's, I'm really curious how this might fit, right? And they'll go, wow, I haven't thought about that before. I want to have a conversation. And this all starts with a conversation, not buy my product. You make them curious. You know, that is unique. I haven't seen that before. I need to have a conversation with this person. And the fact that I've got 5 people sitting in the room means one of them is more likely to put their hand and go, I'll talk to this person. Somebody else comes in and they go off all to that, talk to that person, you know, the next person coming in.
Amazing and personable. So I think that's very encouraging. Chami, do you feel that your organization works in the same way? Is it similarly direct in terms of interaction and feedback on the potential of new solutions that may come across your desk?
Yeah, you know, I think there's a little bit of this and a little bit of that, you know, that that Chris has said that is complementary. But the one thing I will tell you though is that we are in an industry that is traditionally been very cautious. Okay, some people use the word risk averse. I just say it's cautious. You know, the industry has been built to de-risk actually operations. So any new technology that comes along in the mining industry needs to be looked at a little bit more carefully, simply because it can disrupt an operation in more ways than one can even imagine, right? You know, there's that theory of unintended consequences. And so that theory holds very true when you look at technologies coming into this complex system of mining. You know, you don't want to have that perfect domino drop that then causes problems downstream somewhere. So in the mining industry, any technology needs to be proven in a way that is in a place that is as closely resembling the final destination of the technology as possible. So when newcomers come into the industry with a new technology, we really listen to what their story is, right? And we always want to hear, are they actually addressing a business problem over at the mining company side? Because look, your technology idea may be a great idea, but if you don't quantify it in terms of dollars and cents, or how it impacts ESG or some of these other really broader issues, then uptake is going to be very difficult. So in our intake process, we do this bit of an assessment where we really listen to the innovator, and we also even have developed an assessment system which we can activate to ask these questions that allow us to understand where the gaps are. Because look, technology creators sometimes are very technical and not necessarily very businessy. So we want to make sure that we're asking them those questions that are challenging them. You know, can you scale this technology, right? You know, how many of these units of this technology can you produce in a year? You know, can you provide support to someone who is an operation that is in a remote location? So we ask all these other fundamental questions that the operator is going to ask. So our job in the network is to do the translation piece, where we are looking at the vendors and the innovators and hearing them out, and we're also looking at the operators and hearing them out, and then we're doing this perfect marriage between the two to make sure that it's as seamless as possible. And then the other one thing I want to say is that because our network is national with a global impact, we're also able to tell people when they are reinventing the wheel, right? Look, when you look at what's happening in fundamental research, people are getting PhDs and masters by doing work that is similar, but maybe a little bit different, but similar, right? But when it comes to making that into a solution, it sounds a lot like the same thing. So we have to maybe understand that there's distinction between the reason why we do research and development that produces PhD and master students, and research and development that produces commercializable product and service, right? We understand that we need to build the knowledge base up. So people need to be able to be taken to task to understand fundamentals, right? But we cannot assume that every fundamental research idea is all of a sudden going to be commercializable. So we want to make sure that we have that balance. But again, the reason why we're looking at late stage technologies is because we want to make a difference today. We need more metal, right? We all want to have a low carbon economy. We want to do the green transition. So we want to make sure that the technologies that we're identifying are the ones that can be applied sooner than later.
But you know, that's an interesting point, and actually much appreciated, that not only are you working to improve the efficiency and save costs for your members, I think your effort to help, as you say, avoid reinventing the wheel saves researchers, funders, possible, you know, participants and colleagues from spending money and time and effort on something that may or may not have an applicable, applied value in the future to, an immediacy is critical here. And we've heard that in several ways, the urgency for adoption, the urgency for your membership, and also to make sure that there's a relevance and a motivating, perhaps commercial, but applied value in the work that's being done. And I think that also saves people time, even if initially it may be considered kind of
Evan, if I can just add
challenging.
one,
I think it's great.
Yeah, if I can just add an example, recently, and I won't be able to name the company, but recently, we were in front of a company that was telling us that they've developed an in-house solution, right? And as they're telling us about the in-house solution, we're looking at each other going, why on earth did you spend all that time creating this thing that exists over there and over there and over there? So I would say, to the mine operators, right? The mine operators like to come to us to avoid exactly that. Where you end up spinning your wheels, developing something that is already developed at a higher level somewhere else. So again, the network approach allows us to not only understand what the challenges are, but understand where the mining companies themselves are doing work to help them to avoid wasting a lot of time to get a solution when we can quickly point them to say, look, yes, you're in the West Coast, but guess what? On the East Coast, there's a solution that fits exactly your problem over here. So that's why the network piece is so important, and the national scope of the network is important to be able to draw these technologies out, draw these solutions out, and make visible these challenges.
And it's interesting when we talk about these, drawing from a question that's, well, a two-part question that was in the chat. In the vein of sort of reinventing the wheel from the research side, we're also talking about process reuse, water storage, tailings ponds. These are common and long-standing practices. What about looking beyond? Where do you get inspiration, and are there partners looking for, in this case, a description of, are we working at technologies that go beyond standard practice, perhaps bringing water quality to the point of safe release, right, back into a watershed? I mean, these are advanced technologies required for such a task, and there's lots of regulatory challenges associated with that kind of pursuit. But the idea, the core behind a question like that is, how do we think beyond the existing standard practice as well? And do you have working groups within your organization for exploration of those types of, beyond the standard practice from the industry side?
Well, Evan,
Chris, perhaps, yeah.
I'm glad you've asked a question. I guess, we've talked about an in situ process, which doesn't release water. They take water from deep underground, and by regulation, they have to put it deep underground, and that's the way it is. And there aren't surface users in the areas to use them. The question is really, directed towards the mining side of the business, and that there are not discharge regulations, and the federal, provincial, and stakeholders are working on those. The interesting side is this water is actually not rocket science. I've done water treatment the world over, and from a water treatment perspective, that water is kind of boring. What we have is a lot of it, and we need to do it in an environmentally friendly way. But if I was going to pick water that was interesting to treat, it's not that surface water. It's got some organics in it. We need to detoxify and work with it. Man, I was doing, industrial water. If I'm looking at auto manufacturing, I'm looking at metal processing. Those are fun waters, and water treatment engineers can do it. We treat it, we take it, we recycle it, and then we return to the environment, right? That's what water treatment folks do. There's a lot of great technologies out there that can be done with that. A lot of the interesting push has been, engineers and scientists love to use pipes and pumps and power. In about 2013, we started pushing on this line. What about low energy? And H2 Nano is a technology that's taking and detoxifying water using sunlight. But it's a UV technology. You take a UV tube, you push it through, you apply energy, and we do that. But can we use the natural environment to do things we didn't? So instead of metal, pipes, pumps, all these things, UV light. Now, we can float a substance on the surface of a water body. The sun hits it, creates the same radical. So my challenge to those inventors and scientists out there is, can you do what you've always done, but do it in a lower energy way? That's an exciting story. Why did we start asking for lower energy? I can't even think of why. But once we did, we started getting folks coming and saying, yeah, we can do that. We can do this. We can even remove other things from water other than just disinfection. So my encouragement is think about what you're doing differently. Think about it in a low energy format. There are solutions out there we haven't thought about yet.
I'm sure, in addition to the technical insights and the problem sharing that you've both presented today, I think most of the businesses in here will also benefit from your perspective, Chris, on, piquing the curiosity of the industry and, your use of the term storytelling, right? I think it's a very critical piece beyond the technology to ensure that, as Chami was saying, making a business that is functional beyond the technology, that you have a commercializable system, that you're scalable, and that you have a story to tell that is compelling for these possible partners in pursuit of, solutions. And I wondered, I'm conscious of time, but I wondered from one of my colleagues, Nina, the question came up about, before we end, if Chami, you could start and we could go to Chris, what do you wish existed? What is needed right now from your perspective to overcome or I guess move a needle in a progressive direction? Are you looking forward to future funding? Are you challenged by research priorities of universities? What do you wish you could see out there? What are you hoping for, Chami?
Yeah, so I think the first thing for me is that Canada as a country is blessed because we have so many innovation assets. Unfortunately, they're very disconnected. So there are a lot of solutions that exist if you go from Newfoundland all the way to British Columbia. In between there is a lot of resources that are working towards addressing water issues, mining issues. However, we need to bring that to surface. So number one, I think I would encourage the bringing to surface of work that is in progress in a more transparent and visible way. And then the other big driver for us is the future of mining. The future of mining is being driven by all of us because we're all screaming for low energy. We're screaming for electric cars. We're all looking to go away from primarily focused on fossil fuels, but all this is going to demand more mining. So I think getting the message out to the world that in order for mining to produce what it needs, we need to address how mining is going to affect water. And the Chris was saying, the technologies that address water need to become greener technologies themselves. So as we regreen the entire value chain, it's about regreening even how we do the work so that we can produce the minerals and metals necessary to actually do the regreening itself. So this might be a more holistic view of innovation and how it relates. And then we can take away all the silos so that we can learn from each other a little bit easier.
That's interesting and motivating, especially as part of an organization that is hoping to bring together various parties for such discussions. Chris, is that similar for you? What do you wish existed out there?
And it does, and not do I say what existed, but it's really building on. We end up with, at least let me address the research side of it. People are doing fabulous work, and scientists tend to, number one, tell people one time and then go, they're not interested. And really what we need those folks to be doing is not only do the work, but your job is communicating it. And your job is done when it's communicated. I believe there's so much great work out there that the scientists do it and they just walk, they're on to the next problem. Your job is successfully completed when you've done it and you've communicated it. That has to be part of it. And that was that talk about, the demand for low energy solutions, right? We need to be doing it and ensuring the researchers are sharing it, because then the SMEs can meet with them. The researchers are not tech developers. They just aren't. So, but we need the SMEs to be working with the researchers to then take it into the real world. So it's all about communication, right? Your job is done when you've told people the story, and not once, when you've told it again and again and again. That's what we need folks doing, because then the SMEs can hear it, then we can hear it. It is funny. It is a communication. If we could superpower that, you would see technologies evolving that much faster.
Amazing. Well, that's a positive note to end on. I'm conscious I should turn this back over to Benita, but I feel like I'm just getting warmed up. I have a series of questions for you that are pretty lengthy. So as I'll say, for my own reference and others, that we'll continue this discussion sorry, is somebody...
Sorry. Yes, this is Kwang Zhuang from Ottawa. So may I have a couple more minutes?
What I would ask is, could I actually, I was about to say, and I think this will help in what you're asking for. Could we possibly share the information, as we'd said at the start, with you to reach out directly to our speakers today, and of course to others on the call? I'm conscious that we had set a certain limit to the time, certainly for our speakers consideration and also others on the call, but there is an absolute interest on behalf of our speakers and myself to further explore this. So please feel free to reach out directly afterwards if you wouldn't mind, because I'm conscious of time. But thank you to everyone participating, and certainly to our speakers, because ending on the idea that communication and persistence are critical to, in addition to the technical aspects of developing these industries, I think are an interesting note to end on. And I appreciate your time. And Benita, I'll turn it back to you, but thanks again.
Thank you so much, Evan. Thank you, Chami and Chris, for joining us today and sharing your perspectives on a lot of different interesting topics. I just want to quickly mention that on December 13th, we're going to be focusing on another Climate Connection session, which will be focused on the building sector, bringing together industry experts who will present short reverse pitches, just like what you've heard today, on the challenges that they see in the building sector. So hopefully you'll be able to join us then, but I will let everyone go since we're at the hour mark. Huge thank you again to Chami and Chris for joining us, Evan for a fantastic moderation, and for those whose questions were not answered, feel free to connect with our speakers after. Their contact information will be shared, so feel free to connect with them. Otherwise, I hope that you have a lovely rest of your day wherever you are. Thank you and take care.